My name is Aqib Javed Hoque. This video presentation is an overview of our final year project done under the guidance of Professor Kandarpa Kumar Sarma sir. The title of our project is Greenhouse Monitoring System. This project is prepared by me and two more group members. Myself Aqib Javed Hoque and my two teammates are Bidyasagar Mahato and Dweepjyoti Nath. Here are the outlines. Introduction, aim and objective, motivation, org methodology and approach, software use, library use, flowchart, components use, block diagram, Gantt chart, literature review, experimental output and discussions, conclusion, and at last, video of working model. Introduction. Agriculture plays a very important role in our life. In greenhouse, we can control the weather condition, climate condition according to the requirement of the plants. And even at the worst condition, we can get the crops and we can produce that crops which are not seasonable. Next is aim and objective. In this project, our main aim is to build a system where we can monitor the defined parameters accurately and control them. It also focuses on saving water, increasing efficiency, and reducing the environmental impacts on plant production. And here, user can see the atmospheric conditions of the greenhouse plants on the ThinkSpeak website. Motivation. In traditional farming, farmer has to visit the farming land regularly to measure the various environmental parameters such as temperature, humidity, light intensity, etc. to cultivate the right crop at right time. But this system is hectic and fail to produce high productivity as farmers are unable to monitor the parameters accurately. So building such system where farmers can monitor the defined parameters accurately will give us high productivity. Next is org methodology and approach. In this project, we are using sensors to measure temperature, humidity, etc. and microcontrollers to process the data. Microcontrollers perform the required action and sends the data to the ThinkSpeak website using Wi-Fi. Next is software used. Arduino is an open source electronics platform where we write code to perform accordingly. It is compatible with a numerous number of sensors. It is able to read inputs like light on a sensor, a object on a button or sensor, or a Twitter message, and turn it into an output like activating a motor, turning on LED, publishing something online. Next, we have used the ThinkSpeak website. It is an API. ThinkSpeak allows us to visualize and analyze live stream data in the cloud. We have used ThinkSpeak to display and store the value of the data read by sensors. Next is a library used. The first library we have used is Adafruit Unified Sensor Library. The purpose of Adafruit Sensor Library is that it makes sure whether the drivers are working well with the other unified sensors and programs that make use of the system. Next library we have used is DST library. DST library is used for DST series sensors. We are using DST11 sensor to measure temperature and humidity. It is a low cost sensor. The next library is ESP8266 library. ESP8266 is used for ESP boards which have Wi-Fi inbuilt. It plays a very important role as it is all about Wi-Fi. Here is the flowchart. This flowchart explains the part of automation. The device is started using power supply. After that, sensor reads their respective data. All the data are transferred parallelly to the microcontrollers. Now there is three conditions checked in parallel for three parameters. First one is temperature. If the temperature is greater than maximum threshold temperature, the fan is turned on for cooling purpose and it return to the loop. And if no, then there will be another condition check, that is if the temperature is less than the minimum threshold temperature. So if it is yes, then the light will be turned on for heating purpose, and if it is no, then both the fan and light will be turned off and return to the loop. The second condition check is for soil moisture. If the moisture value is greater than the threshold moisture, then the pump will be turned on, and if no, the pump will be turned off and return to the loop. The last condition check is for light intensity. If it is dark, then the light will be turned on, and if it is bright, the light will be turned off and it will return to the loop. Next is component used. So we have used LDR, soil moisture sensor, temperature and humidity sensor, fan, bulb, pump, relay and microcontrollers. Here is the block diagram. The block diagram shows the overview of our model. The microcontroller is receiving data from the sensors and processes in it. It gives the required output to the relays and send the parameter value to the ThingSpeak web where the data are stored and live data are displayed. The first sensor we have used is a DHT11. We are using DHT11 sensor to measure temperature and humidity. In DHT11 sensor, we have three connection data required to use the sensor, that is VCC, ground and output. The parameter of DHT11 sensor are DC 3.3 to 5.5 volt, resolution 16-bit, accuracy of temperature is 2%, accuracy of humidity is 5% RS. Next is a soil moisture sensor. We are using soil moisture sensor to measure the moisture content in the soil. It has 4 pins, that is VCC, ground, digital output and analog output. The parameter of soil moisture sensors are power supply 3.3 to 5 volt, value range 800 and above is a dry soil, 800 to 500 is a humid soil and 500 and below is water. Next is a light dependent resistor. We are using LDR to measure the light intensity of the environment. It is basically a resistor that has an internal resistance that increases or decreases dependent on the level of light intensity experienced on the surface of the sensor. Gantt chart, it shows our progress of preparing our project. As shown in the Gantt chart, our project is completed. These are the literature review from where we have collected the resources and learned about greenhouse monitoring system. Next is experimental output and discussion. This is a screenshot of Arduino sketch. The serial monitor is displayed here where the parameter values are shown. This is the screenshot from ThingSpeak website. Our channel name is Greenhouse Data. This is the screenshot of the graphical representations. The first field chart 1 shows the graphical representation of a temperature. The second field chart shows the graphical representation of the humidity. And here the third field chart shows the graphical representation of the soil moisture. And the rest shows the numerical value of the parameters. So next is conclusion. So our model is a consist of various sensors, microcontrollers and relays. In our project, automation system is done for irrigation purpose, controlling light intensity and temperature. The parameter values are sent to the ThingSpeak website where user can monitor the greenhouse system. Next is video of working model. In the next slide, the working of the project is explained in a video. This is our model for greenhouse monitoring system. We are using Arduino Uno to collect the data from the sensors. We are using NodeMCU to send the data to the ThingSpeak website. This is DHT11 sensor which measures the temperature and humidity. Here is the LDR which measures the light intensity. And this is the soil moisture sensor which measures the water content in the soil. And this is the fan. We have used this for cooling purpose, for automation. Relay for external power supply. And here is the water pump inside in it. These are the sample soils. Right one is dry soil, left one is wet soil. And here is the bulb to give heat. This is the ThingSpeak website where the data are uploaded. The data are sent from the NodeMCU. Currently you can see the number of entries is 197. Scrolling down, this is the first field chart which shows the graphical representation of the temperature. This is the second field chart which shows the graphical representation of the humidity. This is the third field chart which shows the graphical representation of soil moisture, and the rest shows the numerical representation of the parameters. You can see here the soil moisture value is 1024 Let's see its fluctuation. Here the right one is dry swell and left one is wet swell, and now the sensor is in the dry swell. Now let's see what happens when I put the sensor in the wet swell. Now the number of entries is 198. Let's wait for another entries. So here you can see the number of entries is increased to 199. So let's do the swell measure. Now here we can see 451. Previous it was 1024 when it was in dry swell. Now I will show the automation part. So let's start with DHT11. So which measures the temperature. Here we can see the temperature is now 33.20 degrees Celsius. When the temperature will increase more than 34 degrees Celsius, this cooling fan will turn off, which is used for cooling purpose. So let's increase the temperature. So I'm using bulb here to increase the temperature. So here you can see the temperature is increasing. 33.80. It's more than 34 now. Here you can see the fan is turned on. For next is swell moisture sensor. Let's see the automation for irrigation purpose. So currently the swell measure is in the wet swell. So when I'll put it in the dry swell, our motor pump will be on for irrigation. So let's put it. So here we can see now our motor pump is turned on. So when I will again put this sensor to the wet swell, our motor pump will be turned off. So here is turned off. So our next automation is for light intensity. So if I give darkness to the LDR, our bulb will be turned on, and if I give brightness to the LDR, our light will be turned off. So let's see. So I am holding the LDR. So you can see our bulb is turned on. So when I will leave the LDR, it will be turned off. It is turned off. Thank you, and that's all about our presentation.